So now I'd like to invite Vinod Khosla to join me on the stage. Vinod Khosla is the man who was right about AI in healthcare. In December 2011, he wrote a paper called "Do We Need Doctors?", which was published by TechCrunch in January 2012. In September 2016, he wrote a paper called 20% Doctor Included. Last year, we sat on this stage, and people were cautiously asking him, what did you mean by that? And Vinod spoke a lot about the human element of care not being replaced. Now, as we'll get to in my first question, which is going to come in another moment, we all know that AI is replacing many functions of doctors. So, Vinod is a prolific healthcare investor in many sectors: AI and imaging, AI and biomarkers, AI and neurons. A lot of genomics companies, Viome and Loop Genomics, the microbiome, and one Neurotech company called Ellipsis that determines one's depression score based on their voice. That's just a handful of the many. He's a prolific thinker and writer on healthcare. He, in January 2018, came out with a series of papers called Reinventing Societal Infrastructure with Technology, and segment number 7 was Reinventing Health, Disease Diagnosis and Management, and Drug Discovery. So it's a real pleasure to have you here again. Thank you.
Well, it's great to be here, and I loved being here last year, and I love sort of the techie audience here, and so it's always fun.
So yes, so Vinod is a great champion of this conference, for which I'm grateful. And you know, I prepare for this interview a lot, and then he comes and he says, the audience is full of brilliant technologists, just let them ask questions. So please ask questions. I'll start with the first question, though. As I mentioned a moment ago, we as a society no longer discuss the possibility of AI replacing many functions of doctors. It's happening. This time I'd like to ask you the opposite question. What are the potential implications, both positive and negative, the dangers of AI replacing doctors?
You know, look, there's causing a transformation like we are trying to cause is very hard and disruptive. And disruption sounds fun to us. If you're the disrupted party, it's not a lot of fun. You know, ask taxi drivers about being disrupted by Uber, and they say it's not a lot of fun. My monthly income's going down. Now, some of them are peeling off and becoming Uber drivers because they can make more per hour, but it's never fun to be disrupted. Also, when I talk to younger doctors, they're much more open to the idea. When I talk to people well-established, they tell me all the reasons why this still won't happen. So it's interesting. My experience has been the people who are experts in the medical system tend not to believe it. People who are at the top, very top, tend to actually be like the very young doctors, and they tend to believe it because they no longer feel insecure about their own jobs. So you talk to leaders like Eric Topol or Denny Osceola at MGH, and they're very, very supportive of this and even believe that this is the only way to improve healthcare. The people in the middle partially feel threatened, partially feel, yeah, but this is too complex for systems to do that. And it's instructive to look at what AlphaGo did with Go, and what AlphaGo Zero did with Go is even more stunning, because AlphaGo learned from 35 million human games and beat the best human. AlphaGo Zero just had two AlphaGo Zeros play against each other and generated their own games, and they beat AlphaGo and all humans. It's pretty interesting. But it's hard to believe how large that change is. Look, 15, 20 years ago, it was hard to convince anybody on Wall Street that systems could trade stocks against or pick stocks against humans. It's just impossible. Read the literature from 20 years ago till a mathematician called Jim Simmons actually did it and decided in doing it he wouldn't hire anybody out of investing. No analysts, no bankers, no experts. He just said, I'll use math to reinvent trading. His fund's the highest returning stock fund ever, right? And they carry a charge of 50% profit, and you can still not get in because they still outperform every other fund. The same will happen in medicine. When is very hard to predict. I don't think medicine is more complex than stock trading. There's also an equal number of restrictions on information, what's proprietary, what's public, what's not, lots of regulatory concerns.
But we have this ethical obligation hanging over our head.
And I'm glad you brought this up, because I was writing up 2 weeks ago, just some random guy who was a radiologist up a chairlift skiing. And we had this conversation. And I had to turn to him and I say, by the end of the ride, if you're practicing yourself in 5 years, you'll be killing patients every day. Are you prepared to do that? Or are you prepared to test your diagnosis against a system? Almost certainly he will lose. But these radiologists won't go away for the next 20 years. And they will be killing patients. It'll be less clear which patients they're killing because there's diagnosis and misdiagnosis or misdiagnosis aren't subject to checks. Look, it takes time for these things to penetrate. So I think in 5 years, we'll prove in the top 1,000 things you want to do with imaging, you can do better with systems. But when it takes over even 50% of radiology practice, very hard to say, and could be delayed by 15, 20 years. It takes 10, 15, 20 years to have any practice go through medical practice because we are going through humans. Now, if we find ways to bypass this, if Mary Lou's machine or some other MRI machine directly, I have sort of this dream that take even traditional MRI. When you're doing a scan, you do a scan, and then you send it to a radiologist who analyzes, writes a report, sends it to the physician. But when you're doing a scan in real time, you could change the pulse shape, the pulse width, the resolution, everything based on what you're finding. You can only do that in real time. That's when you can't have humans in the loop of that diagnosis. So if you find something, you want to do it at fine grain and find out a lot more, even repeat it multiple times or change the pulse shape to look for different characteristics in an MRI. That's the kind of thing that will become so radical, there's no way to insert a human in the loop. So it's very hard to predict. The trend is very clear, the directions are clear, the rate of change is almost impossible to predict. Will it take 5 years? Or 25, I don't know. But almost certainly in 5 years, people who are still practicing radiology, other than in very specialized situations where there aren't enough systems or data, will be killing people. And that's the ethical issue. I mean, today, the average physician has about as many accidents as if Google's driverless car was allowed to have 1 accident a week. It's just not visible to us. They're documented in large-scale studies. If you go to the Institute of Medicine and search for medical errors, drug interactions, misdiagnosis, missed diagnosis, you'd find horrifying details. Some of these papers are referenced in my 100-page paper that you referred to. It's horrifying how bad it is. It's better than it ever has been. So let me be clear. Medicine today is way better than it was 10 years ago, better than 20 years ago, better than 50 years ago. But is it as good as it can be? No. And are we at the right stage in technology where a technological transformation is possible? Absolutely. Now, Mary Lou talked about collecting a lot of data. One of my beefs is, if you go to the Quest diagnostics menu, there's only 300 blood tests you do. We mostly don't collect the data that human beings can't read. I think that's criminal. We should be detecting 10,000 biomarkers plus per blood test. If we did, 5 years later, we'd be diagnosing things that you couldn't otherwise imagine. I'm almost certain within 10 years, every disease would be diagnosed not by symptoms, but by its broad-scale phenotypic expression. You'll have 10,000 biomarkers, changes in heart rate, changes in the shape of your ECG, changes in your activity, in how often you check Facebook or Twitter. All those are phenotypic expressions of things that will feed back into diagnosing a disease. I love Denny Asiello. He said, in the 70s, there used to be a disease called dropsy. And then we got fine-grained in analyzing it, and the term disappeared. And he said to me a few years ago, almost certainly the term diabetes will disappear, and it'll be 5, 6, a dozen different diseases. They just happen to have one common symptom, poor blood sugar control. But the patients who are at risk of diabetic neuropathy are different than the diabetic patients who are at risk of cardiac events. They should be separate diseases based on the causal mechanisms and systems-level behavior. So the body is not a simple thing. And there may be 3,000 metabolic pathways inside our bodies interacting through tens of thousands of biomarkers of one sort or another, DNA, RNA, proteomes, proteins, metabolites, you can go on. That system is too hard for humans to understand, but if we collect the data, that's how all disease should be diagnosed. And it's a shame in this day and age, most people who have heart disease discover it by having a heart attack. Think about it. The disease started 20 years ago and goes undiagnosed till you have a heart attack, and then you suddenly say, oh shit, I have heart disease. It's silly. Mm-hmm. Sorry, long answer to a short question.
A question from the audience?
Yeah, so I'm curious about how do you handle all the data that's currently available in electronic health records that's just filed in a way that makes it very difficult for a computer to process?
First, it's not hard to process, it's hard to access. Okay? But let me say the following. We have relatively little data in electronic health records. And by the way, the data is biased. So I've seen some analysis that say if you did, say, medical decision support systems from medical records, you'd bias your diagnosis towards billable events because the EMRs were built for billing. And so you'd sort of like ICD code something for the most billable as opposed to the true disease, because that was the purpose. So the amount of data you can now collect, we have a small little company we select. Out of a dry blood spot from a fingerprint at home, we hope we can get tens of thousands of biomarkers. Take it, ship in the mail in an envelope, and go to get real data. I think if you tracked 1 million people with weekly blood blood finger pricks at home for a year, you'd get way more data than the best EMR system could give you. That's not to say useful work can't be derived out of EMRs. In fact, if you want to know what can be done, David Sontag at MIT has done some of the best work in combining AI on medical records. Amazing amount of data of building decision support systems that can have tens of thousands of diagnosis rules, but completely self-derived. So David Sontag's work is the most interesting in that domain. But what I'm saying is that's a small subset of the data, and it has biases built in, mostly. Now, the Danish biobank, much better data set because it wasn't designed for billing. So there was a question back there.
And I agree about David Sontag, who spoke at this conference when he was at NYU before he went to MIT. I absolutely agree.
Can you speak up?
Yeah, thank you. Benjamin from Singapore. So it's amazing and very exciting to have a peek into the future, just from today's lineup of speakers. One of the things that's increasingly apparent is that AI technologies will soon may supplant the human creativity that we all share. And do you see that happening in what kind of time frame? And do you expect to have ways to manage potential dystopic futures that we see sometimes in Black Mirror episodes?
That's probably not. Let me just briefly address it. It's not the relevant. Can AI be more creative than humans? Pretty likely. In fact, we just made our first investment where its only goal in the first is in 5 years to do a top 10 music hit. So
Bravo.
I'll tell you in 5 years whether they did or didn't. But if you look at the complexity of data coming off the human body, can you come up with much better hypotheses of what's going on? AI systems will. If you have an enzyme, can you come up with other enzymes that could do similar things and be subjects for research? Absolutely, AI systems will hypothesize what else to test better than a human scientist could. To your question of a dystopic future, I'm not as worried about it because I think there's many more positive scenarios than negative scenarios possible. And I think in general, this technology can and mostly will help mankind. Now, I've written about the negative side also. I wrote a blog last September about AI scary for the right reasons, about AI in cyber warfare. And it can be very scary. And I do worry about those things. I do worry. I wrote in 2014 about income disparity driven by AI technologies and technology in general. So there are things to worry about. None of this is smooth. None of this is going to be without accidents. The accidents will get a lot of press, and so it'll set us back a lot. So we have to be very careful and very mindful that there are short-term things that are important as well as the long-term goal. But if I'm to say, how do you provide the best healthcare for 7 billion people on this planet at the lowest cost and have everybody on the planet get the highest level of care, AI is the best way. Lots of data is the best way. Data collection mechanisms is the best way to do it.
Was there another question from the audience? Or?
I'll let you keep going.
Thank you.
Oh, there's a question.
Yeah, just a quick one. You mentioned technological transformation, and I think without exception, or at least by general rule, most technology transformations occur in the U.S. or in Western Europe where there's money, and then it eventually trickles down to the poorer nations of the world. Are we in danger here, especially with the self-serving interests of medicine, of not becoming the first adopters and losing the value of AI to areas that either don't have those entrenched or they don't have any doctors, so they're willing to take on things we want?
Well, it depends on the part of AI you're talking about. Okay. In general, I'm not concerned about that. I like to say, and I wrote this in my paper a couple of years ago because this question comes up a lot. First, technology generally has increased the cost of healthcare, and that's worrisome. And that's because every hospital system wants to buy a $200 million proton beam accelerator and advertise how much more they can do for cancer care. And it's completely unproven as a therapy, and the costs go through the roof. The flip side of it is the greatest need exists in a village in India. I'm more likely to get my AI cardiologist accepted in a village in India, managed by a nurse practitioner in that village, than at Stanford Medical Center because the gurus will still be here. Okay? So I think the uninsured, the less insured, those are the best places to get started. And the cost is near zero, and those business models depend on volume, like Google search. So any machine diagnosis of a condition should cost as much as a Google search. And today, we can spend way more compute cycles on a 3-cent ad served to somebody than a $10,000 MRI, should I have knee surgery decision. It's true that that 3-cent ad gets more computing power than that $10,000 surgery decision. That will change.
So I recently heard a fascinating chat between you and George Church about a futuristic world of reinventing nature.
George is way ahead of me.
Please comment on companies or research directions that are opening up new possibilities in healthcare in synthetic biology, genomics, longevity, aging reversal, and beyond.
So let me give you a couple of data points without trying to sort of predict everything. First, sequencing as a cost will go to zero. My biggest worry is the biggest cost in sequencing a full genome will be FedEx, shipping a sample. I actually think $30 to ship a sample through FedEx is going to be by far the biggest component of cost in getting a whole human genome. I think in the next 2, 3, 4 years, the cost will be below $20. Okay? And so the amount of data in that world will explode. If you have that world, you will no longer think of, say, the microbiome as species-level data. You'll get strain-level data. In fact, we already have a company, Viome, that's probably generating a couple of million data points, strain-level data points, by looking at the RNA. It says, what bug in your gut is active? Right? Because no RNA means the bug may be there, it's not active. And this is a complex, nonlinear, dynamical system in your gut. And we want to know what's active, what's being expressed. That kind of thing becomes routine. Viome's trying to do quarterly or annual tests of your microbiome, but at the strain level, right? Not at the species level. Those are examples that add to the data pool I'm talking about. You'll be able to say what diet changes the level of, say, blood glucose for you. And those of you interested in this, Eran Siegel at the Weizmann Institute in Israel has done some of the best work. You can predict. So I'll give you a data point. I know how much time we have. I could go for hours on any one of these topics. They built the models of the human body where for any one person, they can predict what their blood sugar will be in 2 hours based on the meal they're currently eating. By the way, if they sat a nutritionist down with the person, the area under the curve of the nutritionist's accuracy in making a prediction in 2 hours what their blood sugar will be, looking at the meal, is like 0.37. Their system has a 0.77 area under the curve in predicting better than a nutritionist. And it's personalized to the person. They take one microbiome sample once, and then they build a personalized model. AliveCore does the same thing with ECGs. They build a personalized neural net model and then monitor for changes in the model parameters to know if something's changing in your heart condition. So those are really interesting pieces. Where they lead to, it's a little hard to test. But I think of the body as this very complex system of many thousand metabolic pathways interacting through shared signaling molecules. Is serotonin an immune system marker or a mental health marker? It is both. And so understanding these systems, in fact, my dream would be in 10 years, we have a complete, accurate model of every human body based on their genome and their diet. And we can predict what each drug will do, what dosage of drugs needed, and what the response will be to any particular drug or combination of drugs. Like a huge simulation, computational model of every body. That'd be like a dream for me.
Any other question from the audience? Please turn it on.
Okay.
Yeah.
So thank you so much for being with us. One of the challenges that we face is once we add information or change the paradigm, what we track, we overwhelm doctors. And they don't know how to handle that. What's your way of inspiring them by reading more data or different data, they can do better?
Well, I think data is a bad thing. More data is worse for doctors. There's plenty of research in psychology that says humans can't keep more than 6 or 7 pieces of information to work on and make decisions from. So in some sense, when you get to complexity, humans sort of give up. I think what we need to do is get so much data that humans don't even attempt to use it. Okay? And what we do is deliver insights, not data. And so let me say the next 10 years, what we should do is deliver insights that can be a bionic assist to the physician's experience. That means they mediate. Based on what they're learning, we then improve the insights we give into decision-making systems. So I think the next decade will be more about bionic assist for physicians to help them make better decisions in reducing data, not increasing data. Adding more insights, adding more questions, adding more possibilities, but in the end towards simplified decision-making for them. And then narrowly saying, here's a research study, click on this link if you want to understand this particular aspect of it, so they can go deeper if they want to, but the decision is simplified. We have to keep in mind that average clinician's patient visit, the average patient visit is 4 minutes or 5 minutes. There's only so much time. And that's in the Western world, not in places like India and Tanzania, where it's much worse. Doctors often make decisions before seeing the patient. Right? It's just the reality, because patient-doctor ratios are so much worse. That's the world we should gear to help. And I think there's this transition period where the current body of knowledge can help systems learn from doctors. AlphaGo learned from human games and human Go players. And then the next generation of systems in AlphaGo 0 didn't learn from any human games. It just learned enough to play against each other and then just outperformed everybody. By the way, when they trained it to play Go, and they used a strategy called generative adversarial networks that played against each other, they beat the best human players by a mile, but what was stunning was they gave it the rules of chess. And 4 hours later, it beat the best chess-playing systems without knowing anything other than those few rules that are in any chessboard, that black pamphlet, black and white pamphlet. 4 hours, it beat the best chess-playing computers and chess-playing humans in a system that wasn't designed to play chess. So I think this model will work. There's a new branch of research in reinforcement learning that's sort of exciting. It's called reverse reinforcement learning. So instead of giving it data and letting it learn, it can actually watch human observers and deduce what they're trying to do. You can deduce the goals. Something like that might work really well to learn from what doctors are doing in medicine for a while, till you get good enough. So this reverse reinforcement learning sort of sounds like a really exciting new area for AI research. Anyway, sorry.
Arkady Borkovsky.
Given all this, what would you advise to the people who are going to medical school now? So how should they learn to live in that world? And
I get asked that by so many medical school students. So a couple of things. 3-4 years ago, I'll give you 3 or 4 pieces of data, of snippets of something to think about, I should say. It's not data, it's not advice. 3 years ago, I gave a talk at Stanford Med School. I said, if in 20 years I wanted to be a really good doctor, I'd go to the math department, not the med school. The more practical advice I give to med school students is I'd be as diverse in my learning. So, for example, med schools almost never focus on math. I would absolutely I would focus on math, I'd focus on neuroscience, just because they're models of learning, and add diversity to med school education as much as possible. That's like practical advice. If you're already accepted in med school, you told your parents you're going, here's what you should do. Get more diverse in what you take and how broad a background you build. The third thing, and this was advice I gave to Jeff Flyer when he was dean of Harvard Medical School, and I think this was also about 3 years ago. I said, Harvard Med School and Stanford Med School, their admissions criteria really selects for the highest IQ students. I think that's a mistake. If you say what doctors will be doing in 20 years or 15 years, you'll need much more EQ than IQ. And I literally said to the dean of Harvard Medical School, I'd go look at the admissions criteria for USC Film School, which probably selects for mirror neurons and empathetic people, and I'd make them doctors. So, thank you very much.
Thank you, Vinod.
Anything else?
No, we're actually out of time. I look forward to continuing this conversation with you next year in this chair in February.
Great. Thank you, everybody.